EVs get a bad reputation in cold weather. They're known for running out of range super quickly. They charge too slowly. Tesla heat pump is about changing all those notions and making an EV for all kinds of weather.
The biggest innovation, definitely for our team, is the heat pump system.
The easiest way to think about a heat pump is like an air conditioner in reverse.
An air conditioning system takes heat out of your house and pumps it to the outside environment, which is hotter. A heat pump harvesting heat when it's cold outside and pushing it into the cabin of the car.
You know, the basis of it is just around like using the energy you have to make the vehicle more efficient.
It works together to pick the source that makes sense given the conditions that you're in. But it can also turn inward. In really cold weather, where other heat pumps fall short, it can keep the cabin comfortable and generate its own heat and prioritize power.
We first introduced heat pump system in Model Y, but now we have it on all platforms, 3, S, and X.
So heat pumps are not a new concept, but a lot of times when someone implements a heat pump system, they do that by adding a lot of components. And we wanted to implement the benefits of a heat pump system, but at the same time reduce the complexity. So the idea we came up with, we're calling it the super manifold. And it's basically a 2-layer PCB assembly. This section in the front is all of the refrigerant channels that would normally be separate components and separate tubes all connecting things together. We did a similar thing with the coolant components. So we have a layer in the back that's all of the coolant channels all plumbed together. This would normally be 15, 20 separate components in a car, and we've made it into one assembly that's all together.
In order to achieve the functionality of the heat pump, we needed a new configuration for our coolant loop. So we could have done that pretty easily just by adding an additional valve, but that would have been more expensive and it would have made the car harder to build. What if we tried to combine those two valves into a single valve?
And that's kind of how everyone thinks here. I'm doing two things that are almost the same. In one case, I'm throwing heat out, and in the other case, I'm adding heat in. Maybe I should just put those together and have system integration.
So this is the design that we ended up with after many convolutions, and we call it the octavalve. And it's very simple. It's got a barrel inside that turns. Depending on the mode, we're activating different pairs of ports.
Depending on the conditions, the energy efficiency of heating, you might be using 3 or 4 times less energy.
If you can carry a bigger load, more cargo, more passengers, and you can still get to your destination while consuming 15 to 20% less energy, it's significant. And that is something that's not quite apparent by just looking at the car. You really have to experience it.